Very good. Expansion of liquids. When we discuss the expansion of liquids, liquid cannot stay by itself in space. So it has to be taken in a vessel, and I have considered a liquid taken in a vessel with a certain volume, and when I heat it through a particular temperature, you can see that the liquid inside is expanding. But what you observe is not the exact expansion. The expansion of the liquid here is taking place what? An apparent expansion. Liquid undergoes an expansion which is called apparent expansion. It is not the actual. Alright? And therefore, if you want to find the actual expansion of the liquids, you have to consider the expansion of the vessel also. The solid vessel is also expanding a little bit, and along with that only you can consider the actual expansion of the liquid. So you can see that actual expansion of the liquid will be equal to apparent expansion plus expansion of the solid. Expansion of the solid. That is the vessel. So this is the actual expansion or real expansion of the liquid, apparent expansion plus expansion of the solid. So to calculate the real expansion coefficient, the volume expansion real will be equal to the apparent expansion coefficient plus coefficient of volume expansion of the solid. So this is the way you are relating the coefficients of volume expansions of a liquid along with the solid in which it is considered. So this is a very important thing in the case of expansion of liquids. And another point to be noted is that, so this understood, and therefore we go to the next one, that suppose I take the expansion of water. Suppose this is water, okay, and I increase the temperature of water from 0 degrees Celsius to, let us say, 100 degrees Celsius. Now if you observe it closely and plot the volume change with respect to temperature. Volume change with respect to temperature. This is volume of water and this is temperature theta. Okay. So, when it is at 0 degrees Celsius, let the volume be here. And if I go on increasing the temperature, what I could see is the volume initially decreases and comes to a minimum and then goes on increasing. So this volume of the water reaches to a very low value, okay, and this happens at 4 degrees Celsius. And at 4 degrees Celsius, the water will be having the minimum volume, and then afterwards it is going to be increasing. So first from 0 to 4 degrees and 4 degrees above it is going on increasing. And this kind of expansion, irregular expansion, we call it as anomalous expansion. Anomalous expansion of water. Now actually this is a boon for the flora and fauna which is found in the cold countries And in this cold countries, at winter season, the water will be frozen on top. On top layer of water, it is always frozen and it is solid. But after a particular thickness, below that frozen part, you can find the water with the proper temperature, in which the living beings are formed. I mean the fishes and what do you say, the underwater plants and other things being seen. So only on the top layer the frozen part is there. Underwater, under that there will be water present. Now this upper layer is freezing because of this one, and 4 degrees Celsius above that, what happens is again the expansion of water is there. So this 4 degrees Celsius is the reason for this anomalous expansion, is actually the reason for only the upper layer is freezing and below that you can find the water. So it's very important thing to be noted for water. So real expansion condition for liquids and the anomalous expansion of water. It's very, very important. And another thing is that when you consider the variation, expansion of solids and liquids, in general, we can find the density also varies. Density also varies. Now, density variation, you can consider generally like this, that volume V equal to V0, that is volume at 0 degrees Celsius, into 1 plus gamma theta. Now suppose I take a particular mass of liquid or solid. That mass will remain constant before heating and also after heating. Now mass being constant, I can take this as mass divided by density at expanded state will be equal to mass divided by density at 0 degree Celsius into 1 plus gamma theta. Now from this mass and mass goes, and you can find that the density, that is 1 by density is equal to 1 plus gamma theta divided by density at 0 degrees Celsius. Therefore, the final density will be equal to the 0 degree density divided by 1 plus gamma theta. So, as the volume increases, the density is decreasing as per this criteria. This is also another point to be noted in the case of expansions in general. But in solid, you cannot see much difference because expansion is very, very, very small. But still there is a variation that you can use this to find the variation in density. But liquids and gases you can find very fast or very rapid change in this density. Okay.